Good morning, students. Today we are discussing about some problems based on types of functions. The question is that check the injectivity and surjectivity of the function from set of real number to set of real number defined as fx equal to 3 minus 4x. So first we check that this function is injective or not. 3 minus 4x. The function is defined from set of real number to set of real number as fx equal to 3 minus 4x. Let x1, x2 belongs to our domain. Because both the sets are set of real number, so we start with, we are taking here two elements of the domain x1 and x2 such that fx1 equal to fx2. That means the images of x1 and x2 are same. According to equation first, 3 minus 4x1 equal to 3 minus 4x2, because fx equal to 3 minus 4x, this gives us minus 4x1 equal to minus 4x2. This implies that x1 equal to x2. So fx1 equal to fx2 shows that x1 equal to x2. This implies that f is 1 1 or infinity. Now next part on to surjective. Here is 1 1. Let y belongs to our codomain. Here we want to check that each element of the codomain will be the image of some elements of domain R. Then fx equal to, then there exists x belongs to R such that fx equal to y. That means 3 minus 4x equal to y. So 4x equal to 3 minus y. This implies that x equal to 3 minus y upon 4 belongs to our domain, such that fx equal to f 3 minus y upon 4 equal to 3 minus 4, 3 minus y upon 4, 4 to 4 cancel out. This implies that fx equal to 3 minus 3 plus y equal to y. So f is on. In this part we want to check that the function is surjective or not. So for this clearance we take any arbitrary point y in our codomain set of real numbers R. If y is the element of codomain, then there exists x belongs to R for the condition of 1 2. If y is the element of R, then some element of domain should be in condition that the image whose element will be equal to y. So there exists x belongs to R such that fx equal to y, but fx is defined here 3 minus 4x. So 4x equal to 3 minus y, x equal to 3 minus y upon 4. Clearly for each real number y, 3 minus y upon 4 also be a real number, so it will be an element of x. The first thing is that this x should be the element of the domain R. Now we check that is the image of this element is y or not. So we check that fx equal to f 3 minus y upon 4 f. This is the value of x. So put there fx equal to 3 minus 4x. 3 minus 4 in the place of x, we put 3 minus y upon 4, so we have y. So this shows that f is onto means 7. So this is the problem based on the types of function. Now I am taking one more problem based on type of function. The question is that check the injectivity and surjectivity of the function set of real number to set of real number defined by fx equal to 1 plus x square. First, 1 fx equal to 1 plus x square. The question is defined in this condition. We start with let x1, x2 belongs to R. These are two elements of domain such that fx1 equal to fx2. x1 and x2 are two elements of the domain, and we want to show in the condition fx1 equal to fx2, and we want to show that x1 equal to x2. So according to the definition of this function, fx equal to 1 plus x square, so this become 1 plus x1 square equal to 1 plus x2 square. This implies that x1 square equal to x2 square. This implies that x1 equal to plus minus x2. So fx1 equal to fx2 not implies that x1 equal to x2. So f is not 1. Now we check that onto since fx equal to 1 plus x square, here 1 plus x square is always greater than or equal to 0 for every x belongs to R. This implies that range of f is set of positive real numbers. That means this implies that range of f is proper subset of set of real number. This implies that f is not onto. We have clearly defined in previous questions, if range of the function is the proper subset of the codomain, in this condition function is always into. So here we are observing there, for every value of x square is never negative, it should be minimum 0. So this value is always greater than to 0 for every value of x. So range of f is set of positive real numbers. That means range of f the proper subset of codomain. So f is not 1. Thank you. Now I am taking one more problem based on types of function from the chapter relation function from your NCERT book. In this question, the function is defined on the sets. So here question is that let A and B are two sets show that function defined from A cross B to B cross A. You know well, A cross B represent the set Cartesian product of sets containing the ordered pair of the numbers whose first element of set A and second element of set B. So this function is defined from A cross B to B cross A, defined as f ordered pair AB equal to BA is bijective. So how can we solve this question? 1 1. First we check function is 1 1 or not, or injective. Let A1, B1 and A2, B2 are the element of A cross B. A1, B1 and A2, B2 are the element of A cross B. This such that, this is a condition, such that F A1 B1 equal to F A2 B2. We take two ordered pair from A cross B, and the condition the image of A1 B1 is equal to the image of A2 B2. According to the definition, F AB equal to BA, this implies that B1 A1 equal to B2 A2 by definition. By the property of ordered pair, this implies that B1 equal to B2 and A1 equal to A2. Two ordered pairs are said to be equal if their corresponding elements are equal. This implies that A1 B1 is equal to A2 B2. So F is 1. This is the first part of the question. We take a two ordered pair from A across B having the condition image of A1 B1 is equal to the image of ordered pair A2 B2. According to definition, F AB equal to BA, so this will be equal to B1 A1 and this equal to B2 A2. By the property of ordered pair, two ordered pair are said to be equal if their corresponding elements are equal. So B1 B2 equal to A1 A2. Now A1 B1 equal to A2 B2, so F is equal. Now we check on let BA belongs to B cross A. We want to check that each ordered pair of B cross A should be the image of some ordered pair of A cross B. So we pick here BA belongs to B cross A. By the definition of Cartesian product, B will be equal to B and A will be, B belongs to B and A belongs to set A. This implies that A belongs to A and B belongs to B. That means AB belongs to A cross B. So F AB equal to B. So for every BA belongs to B cross A, then adjust AB belongs to A cross B such that AB equal to A. So this implies that F is onto or surjective. So F is bijective. Thank you. Today I am taking one more problem based on types of function. This is a function f defined from set of natural number to set of natural number, defined as fn equal to n plus 1 upon 2 if n is odd Fn equal to L by 2 if n is even for every natural number n. Check that the function is bijective or not. So here we start with the definition of function. Fn equal to n plus 1 upon 2 if n is odd, n upon 2 if n is even for every natural number n. 1 1. Since 1 and 2, 1 and 2 are the element of domain. F1, image of F1. 1 is the odd number, so according to definition, the value of n is n plus 1 upon 2. So 1 plus 1 upon 2 equal to 1. And F2, 2 is the even number, so we take this definition. F2 equal to 2 upon 2, again equal to 1. Here F1 equal to F2, F1 equal to 1, F2 equal to 1, so F1 equal to F2, but 1 is not equal to 2. This implies that F is not 1. Really? We choose here 1 and 2 are two numbers from the natural numbers. 1 is odd, 2 is even. So from first value of natural number 1, this is odd. So we use this definition. F1 equal to 1 plus 1 upon 2. So here F1 equal to 1 plus 1 upon 2, that means 1. Here F1 equal to, sorry, and again F2 equal to, we take this value 2 upon 2 equal to again 1. So here the image of two elements 1 and 2 are same, but elements are not same. This shows that F is not 1 1. Now we check that for on to let case 1. Case first. Let n equal to 2m plus 1 belongs to n. Then there exists 4m plus 1 belongs to n such that f 4m plus 1 equal to 4m plus 1 upon 2, that means twice m plus 1 upon 2, 2. So f 4m plus 1 equal to m plus 1. Case 2. Let n equal to 2p belongs to n. Then there exists 4p belongs to n such that f 4p equal to 4p upon 2 equal to 2p. So f 4p equal to 2p. I am repeating again because this question is defined on two numbers, one is odd and one is even. So suppose that in first case let n equal to 2m plus 1. We know that well, every number if we take odd, which can be represented in the form of 2m minus 1, 2m plus 1 or 2m plus 3. So this n is odd number because our domain is set of natural number, our codomain also a set of natural number. So we want to check that in question each number of this codomain is the image of some numbers of the domain. So first we check, we take here from the codomain, one number which is odd number. So in this condition, if 2m plus 1 is odd number, so then there exists 4m plus 1. If 2m plus 1 is odd number, so 4m plus 1 also odd. This is in codomain and this is in domain. So we want to check that the image of this 4m plus 1 is 2m plus 1 or not. So here we check that by the definition fn equal to n plus 1 upon 2 in the condition of n is odd. So here 4m plus 1 is also odd. So 4m plus 1 plus 1 upon 2, 2m plus 1. That means each odd natural number of codomain is the image of the sum 4m plus 1 of the domain. Similarly, now we take n equal to 2p. Each even number can be expressed in the form of 2p, 2m, 2q, where p are some natural numbers. So we want to check that this, because this set of natural number codomain containing odd or even. So now we take even number. So for this even number we have a natural number 4p in domain such that we check the image of 4p according to definition f 4p equal to 4p upon 2, 2p. So this 2p is the image of 4p. So each element, each odd and even element of the codomain, there exist some odd or even numbers in domain whose images are in codomain. This implies that f is onto. So this implies that f is not